In the chronicles of human progress, there emerges a singular figure whose intellectual gravity has left an indelible mark on the very fabric of our understanding. Imagine a mind so profound that it reshaped the contours of science and philosophy, propelling us into a new era of enlightenment. Today, we enter the realm of Sir Isaac Newton, a solitary genius whose insights not only pierce the veil of the unknown, but also wove a cosmic narrative that continues to resonate with the very essence of our existence. As we embark on this exploration, prepare to witness the gravitational pull of Newton's ideas, where the ordinary becomes extraordinary and the mysteries of the universe unfold in a mesmerizing dance of intellect and discovery. Isaac Newton, born on January 4, 1643, in the quaint hamlet of Woolsthorpe, England, Newton's legacy transcends the boundaries of time, leaving an indelible mark on the realms of science and philosophy. Newton's era was a cauldron of intellectual ferment, with minds like Galileo, Kepler, and Descartes contributing to the alchemy of knowledge. Against this backdrop, Newton emerged as a luminous force, reshaping the contours of understanding with his revolutionary ideas. His pioneering work in mathematics, physics, and astronomy forged the very bedrock upon which modern science now stands. Newton's personality, marked by an unwavering determination and insatiable curiosity, fueled his scientific pursuits. Notoriously private, he was an introverted genius whose inner world was a symphony of complex thoughts and contemplations. Yet, this reclusive demeanor belied a mind capable of unraveling the mysteries of the universe. As external events unfolded around him, Newton approached his work with a discerning eye, extracting order from the chaos of the world. The tumultuous times of the scientific revolution and the English Civil War shaped the crucible in which Newton's genius was forged. His voracious appetite for knowledge transformed external upheavals into catalysts for intellectual exploration. One of Newton's extraordinary initiatives, the Principia Mathematica, published in 1687, stands as a timeless testament to his genius. In it, he laid out the laws of motion and universal gravitation, forever altering humanity's perception of the cosmos. The impact of this magnum opus rippled across the fabric of society, transcending scientific circles to influence socio-cultural progress. Newton's work was a timely game-changer, aligning with the burgeoning age of Enlightenment. His ideas catalyzed a paradigm shift, propelling mankind towards a new era of reason and empirical inquiry. The Principia became a lodestar, guiding subsequent generations toward a deeper understanding of the natural world. The profound implications of Newton's laws extended far beyond the realms of science, permeating the very foundations of society. They became integral to the technological advances of the Industrial Revolution and laid the groundwork for modern physics. Newton's principles were not mere academic abstractions. They were the building blocks of progress, shaping the trajectory of human civilization. While the tapestry of Newton's life was woven in England, his influence traversed borders. His tenure as the Lucasian Professor of Mathematics at the University of Cambridge provided a platform for collaboration with eminent figures like John Flamsteed and Edmund Halley. It was within the hallowed halls of academia that Newton's ideas found resonance, echoing across continents. Newton's travels and sojourns, though less extensive than some of his contemporaries, were nonetheless impactful. His tenure at the Royal Mint, where he served as warden and later master, underscored his pragmatic approach to worldly matters. Newton's acumen extended beyond the ethereal realms of theory. He actively contributed to the economic stability of his nation. His interactions with fellow luminaries were not without tensions. The rivalry with German mathematician Gottfried Wilhelm Leibniz over the invention of calculus is a chapter steeped in intellectual fervor. The calculus controversy, while a blemish on Newton's interpersonal relations, also highlights the competitive spirit that fueled scientific progress in this epoch. In considering the uniqueness of Newton's contributions, it is imperative to contrast him with his predecessors and contemporaries. Unlike the alchemists who preceded him, Newton rejected mystical notions, embracing empirical evidence and mathematical rigor. His laws of motion and universal gravitation were not mere continuations of existing thought. They were revolutionary departures that illuminated the path toward a new scientific paradigm. Newton's Principia and Optics, published in 1704, showcased his profound insights into optics and color theory. His corpus of work transcended disciplinary boundaries, laying the groundwork for advancements in physics, astronomy, In mathematics, the gravitational pull of Newton's ideas extended beyond the confines of his era, influencing subsequent luminaries like Albert Einstein, who acknowledged standing on the shoulders of the great Englishman. In contemplating Newton's distinctive principles, it is impossible to ignore his formulation of the three laws of motion. These succinct yet profound statements encapsulated the dynamics of objects in motion, providing a universal framework for understanding the physical world. Newton's laws transcended the specificity of earthly phenomena, becoming guiding principles that navigated the cosmic dance of celestial bodies. Turning our gaze to the three laws of motion, Newton's first law, often known as the law of inertia, states that an object at rest will remain at rest, and an object in motion will remain in motion unless acted upon by a net external force. This fundamental principle permeates everyday experiences. Consider a car coming to a halt when the brakes are applied. The motion ceases due to the force exerted by the braking system countering the car's inertia. Similarly, a soccer ball kicked across a field eventually slows down and stops as external forces like air resistance and friction act upon it, aligning with Newton's first law. Newton's second law introduces the concept of force, stating that the acceleration of an object is directly proportional to the net force applied and inversely proportional to its mass. In practical terms, this law explains why it's more challenging to push a heavy object than a lighter one. Take, for instance, pushing a shopping cart versus pushing a car. The greater mass of the car requires a more substantial force to achieve the same acceleration. This law forms the basis for understanding the mechanics of various objects in motion, from cars on the road to projectiles in flight. The third law, perhaps the most intuitive, asserts that for every action, there is an equal and opposite reaction. This law explains the dynamics of interactions between objects. When you swim, the force exerted by your arms propels you forward by pushing water backward, an action and reaction in perfect equilibrium. In rocket launches, the expulsion of gases downward propels the rocket upward. Newton's third law permeates countless scenarios, showcasing the delicate interplay of forces that govern our physical world. The law of universal gravitation, a pinnacle of Newton's intellectual prowess, unified the terrestrial and celestial. It was a revelation that the force governing the fall of an apple mirrored the celestial ballet of planets around the sun. This unifying principle not only explained the movements of heavenly bodies but also resonated with the collective human consciousness, forging a connection between the mundane and the cosmic. More in detail, this mathematical formulation elegantly encapsulates the gravitational force between two objects, emphasizing the inverse relationship between the distance separating them and the strength of the gravitational pull. In accessible terms, it implies that every object with mass attracts every other object in the universe with a force directly proportional to their masses and inversely proportional to the square of the distance between their centers. This law not only provided a unifying principle for celestial and terrestrial phenomena, but also established a mathematical framework that harmonized with Johannes Kepler's laws of planetary motion. Kepler's laws, derived from meticulous observations of planetary orbits, found their mathematical equivalents in Newton's law of universal gravitation, offering a seamless transition from empirical observations to mathematical precision. In the grand mosaic of scientific principles, Newton's laws form a coherent and interconnected framework that extends far beyond the pages of theoretical treatises. These laws, woven into the fabric of our understanding, not only unravel the mysteries of motion and gravity, but also guide our comprehension of the universe's intricate dance. Beyond the celestial realms of physics and mathematics, Sir Isaac Newton's intellectual pursuits extended into the realm of theology. A fervent believer in a divine creator, Newton's convictions led him to explore the intricate tapestry of the universe as a manifestation of God's design. His writings, particularly those on biblical prophecy and his studies in alchemy, reflect his deep theological inquiries. In addition to his metaphysical reflections, Newton engaged extensively in the field of chemistry, conducting alchemical experiments and seeking the philosopher's stone, an elusive substance believed to transmute base metals into gold. This facet of his work, though often overshadowed by his contributions to physics, underscores Newton's multidimensional curiosity and the breadth of his explorations. Newton's legacy endures not only in the annals of science but also in the annals of time. His death on March 31, 1727, marked the conclusion of a life dedicated to unraveling the mysteries of the universe. As we reflect on the extraordinary tapestry woven by this solitary genius, we recognize that Newton's contributions were not mere threads but luminescent strands that continue to illuminate the path of human progress.